How about Gaussian elimination? This is a quite interesting topic. First, when I learned it, I had some trouble how to do it, but then I got to know which points are very important to have a look at. And I think the most important thing is to write it very structured, to write the matrices you use very structured, and always write what you do. And the third thing you should memorize is you should try not to apply the same operations more than once. Because when you do that, then you will go around in circles, and then you will not come to the solution very quickly, of course. So these 3 tips you should maybe keep in mind, or maybe when you have trouble, maybe think of those 3 points. Yeah, and other than that, I would say it's quite doable. Meanwhile, I like to calculate matrices with a Gaussian elimination. I think it's not too complicated when you have like 3×4 matrix or something like this. Maybe when you have 99 times 100 by 100 matrix, then it may be more complicated, but then you use a computer or something else anyway. But in the exam, at high school or at college, I mean, you usually have 3×4, 2×3, you don't really need the Gaussian elimination, but 3×4, 4×5, this is something very typical, and I will also show you how it works. My German video already has around 63,000 views on that, so I decided also to make an English language video, and I will show you how it works with an example in the following video. Hi guys, now I'm going to show you how to use Gaussian elimination and also what it is actually. So Gaussian elimination, we need to solve a system of linear equations, or also called a matrix, by manually. So we don't use calculator, or maybe this one, because it cannot calculate those systems of linear equations, but it's just a simple one. But we don't want to use a professional one which can calculate the solution in no time, but we want to do it manually. So let's just have an example. So we need a system of linear equations, and therefore I thought about a 3×4 matrix. And 3×4 means we have 3 rows and 4 columns. So the example is 2x1 plus 2x2 plus 4x3 is 46. 3x1 plus 7x2 plus 1x3 is 94, and 1x1 plus 3x2 plus 2x3 is 43. So we have 3 equations, and we want to know, the goal is always to determine what is x1, x2, x3. So you can also imagine it like this. We have 3 bananas, 2 oranges, and 4 potatoes, and those together cost $46, and then we want to know what costs 1 banana, 1 potato, and 1 orange. And therefore we need to apply some calculus. And the goal is to, there's a special way to write it down, which is called a matrix. This is not really a matrix, but a matrix is, for example, this. So we omit those x, and we just write the coefficients, and then it looks something like this, for example. And we have some numbers here, maybe 4, 3, 2 or something, and that would be the solution. So the thing it works, this structure, is we take the coefficients, just the coefficients, and the right side, the solution, and we write those coefficients in a matrix. So we don't have to write the x all the time, and it gets a little bit easier, and the overview is a little bit better. So this actually is already the goal, what we want to have. So we write this at a matrix, then we calculate, and then the goal is to change the matrix until it looks like this. So this is called a step form, so that we can easily see, okay, if we would add those x again, like x1, x2, x3, then we see we have isolated the coefficient of x1, or we have isolated x1 because 1 we can always write or omit, right? So we have isolated x1, and now we can say x1 is 4, and x2 is 3, x3 is 2, and that's what we want to have, right? We want to have a matrix where we have isolated the variables, and then when the variables are isolated, we can easily tell the solution. And the thing we get to this solution is to apply this elimination procedure. So we just start, and first step is to write it down as a matrix, so it gets a little bit better to look at. So 2, 2, 4, 46, 3, 7, 1, 94, 1, 3, 2, 43. Okay, so this is our first step, and so we just took the coefficients and the solution and we wrote it in a different way, but it's still the same information. And to make it a little bit more structures, we add Roman numbers, so that if you apply this procedure in an exam, the teacher or professor or whoever can easily see what are you doing there. And it may happen if you have a long calculation that you make a mistake. It can happen, and then the professor or the corrector in general, he can see where you made a mistake, and then he can maybe give you partial credit, or but he knows what you're doing, and this is always better. So this is the first matrix, and now what we are going to do is we have to apply calculus. We have to apply some operations so that we can get closer to this one. And the thing always is you have to have a little bit of training, and then you can see actually what equation can be like added or subtracted or multiplied or something, and added to another one, so that you can form this step. The step form. Okay, so the first thing I noticed at this example, okay, we have 2, 2, 4, 46, so it all is theoretically divisible by 2. So what I do is I say 1a is 1 divided by 2. So it makes everything a little bit easier, because these numbers may get too big or too ugly to calculate in the head. So I just, if I see it can be divided by 2, I just do it, right? So 1, 1, 2, 23, and that's already my first step, right? Okay, and not to make it too complicated, and this is always where I make mistakes. I do several steps in one matrix already, and then that's where mistakes happen. So if you have any doubts, or if it gets too complicated, just do it slowly, and one more step in between. So we just divided the first equation by 2, and now what can we do? We see, okay, there's the 1, there's the 1, there's 2, there's the 2. Okay, that fits quite well. So we just say 1b is, we take 1a and subtract 3. And also one thing I didn't say so far, but it doesn't really matter when you calculate how you want to have the order of the step formula. So it could be that in the first row I have the 1 here, then in the second I have a 1 here, and the third I have a 1 here, right? It doesn't really matter which order I have of the rows, but it does matter. I mean, the goal is always to isolate the variables. The order is always changeable, so I could write the first line instead of the third and the third instead of the first. I could like switch it. This is not a problem. So we just do it. 1b, 1a minus 3, so 1 minus 1, 0, 1 minus 3 minus 2, 2 minus 2, 0, 23 minus 43 is minus 20. So that looks a lot easier. So we already isolated x2, and so let's maybe just finish this step. So we just take 2 and 3 from above. 94, 3, 2, 43. Okay. So what else can we do? 1c is 1b divided by minus 2. And then we have isolated x2, and 1 in this case is 10. So let's just do it. 1c is, okay, 0, then we have 1, 0, and 10, just as we said. And now I would like already to do the next step within this, because I already finished the first line. Now I can already use it, but that's why we use those Roman numbers, not to get confused, so the structure stays very clear. Also, if you made a mistake at the end and you see that the result seems to be not logical, then you can also follow your own steps to correct mistakes. It's also a big advantage. So we just say 2a in this case. We want to eliminate the 7, so we take 2 and subtract 1c. It's already from the next step, right? So we just do the step 2a. So we have 1c, there's 0, so 3 stays the same. Then, as we said, 7 minus 7, it's like 7 minus 7 times 1c, which is, yeah, so it is a 0. Then we have 1 minus 7 times 0 stays 1. 94 minus 70, 7 times 10, is 24. That's 17, 18, 19, 94. Right. Then next step, what else could we do? We have third line, we didn't do anything yet. So third line, we want to eliminate the 3. Therefore, we say 3a is 3 minus 3 times 1c. 3a, then just what we said is 1 minus 0 stays 1. Then we have 3 minus 3 times 1 is 0, because that's what we want to have, right? Then 2 minus 3 times 0 is 2. Then 43 times minus 3 times 1c minus is 30. So 43 minus 30 is 13. So this looks already quite good. Now what else do we have to do? We want to eliminate the 3 in this case. I think 3 minus 3 times 3a looks quite good. I mean, I could also do it the other way around. I could say this is also possible always, but the thing is, you will want to make it easy. Life should be easy. So I could also say 3a minus a third times 2a, but of course this would be maybe a little bit, it wouldn't be easy to calculate, but it's possible. So, as we said, 2b is 2a minus 3 times 3a. Okay, so this 1c already looks very good. 0, 1, 0, 10. 2b. 2 times 2a is 3 minus 3 times 3a is as we wanted it to have 0. What else? 0 minus 3 times, okay, this stays 0 minus 0, still 0. 1 minus 3 times 2, so it's 1 minus 6 is minus 5. 24 minus 3 times 3a, this is 39, so we have 24 minus 39 is minus 15. So what else? We have, okay, let's maybe just insert another step so that it doesn't get too complicated. So we just take the equation from above, 13, and looks already almost finished, like we have already there, 1 for x2, 1 for x1, but still here, doesn't look too nice yet. And what we are going to do, let's maybe first do this step. That's always easier to, if we had a 1 here, then we can calculate it easier, like minus 5 and 2. I mean, we could do it already like this, but the calculation would be a little bit more difficult. And if it gets difficult, it's also easier to make mistakes, right? So we just insert another step and then be sure that the result is correct. 2c, actually. So 2b divided by minus 5. So we just insert the step before we continue. 1c already looks good. So 2b, 2c now. 0, 0, nothing changes. Minus 5 divided by minus 5, 1. Minus 15 divided by minus 5 is 3. So let's just finish and make a new step then. This is almost finished, and it's quite easy now. We say just 3a minus 2 times 2c, right? Now this is quite easy. There we could have also done it like this, but this is more easier now. So we say 3b, as I just said, is 3a minus 2 times 2c. So 1c stays the same. Then 2c also looks very good. Now 3b. So we have 1 minus 2 times 2c, of course, stays 1. That's what we wanted to have. 0, 0, of course, 0. Now 2 minus 2 times 2c is 0. 2 minus 2 is 0. 13 minus 2 times 2c minus 6 is 7. And okay, we don't have the step form yet, but we have isolated the variables. So in the last step, what we do, I mean, it's not necessarily because we already have the solution, but what we do now is just we bring it into a nice form. So 3b at the beginning, 1007, then 1c. We can also, if you want, you can also change, like within the calculations, like in this step we could have already switched the rows so that it looks nice, but it's usually I do it at the end, because when you do it at the beginning you're not sure what will be the where the 1 will be, so just at the end, and then you don't have to switch all the time, just once. And 3b, then 1c we said, 10, and then the last one, 2c, 0, 0, 1. Now this is a nice step form. And this is the solution. So we have x1, x2, and x3 isolated, and we now know what the variables actually what the solution is to the single variables. So we have the solution, we can write it down. Now it depends on the exercise, what is really the question in the exercise. Maybe it's also possible, maybe if it's a text exercise, like as I said before, we have 2 apples, 2 oranges, and 4 potatoes cost $46, and so on, and you have more information given and you put it into the system, then of course you have to write maybe a sentence and say 1 apple costs $7 or something like that. Something like that. So, but in this case we just write down the solution because we didn't have a lot of text as a question, but just the system of linear equations. So this is the solution. So actually we saw it's not too difficult. Okay, in this case maybe the example is also quite easy, but it can happen that you also have fractions or negative numbers, and this is where it can be complicated. And this is also an example with just 3×4 matrix. Of course, it can be much more complicated if you have more equations and difficult numbers, but the procedure actually is always the same. So look out for numbers that fit together, like in this case okay, maybe in this case the first and the third row fit together quite well, so that's why we used to eliminate the numbers, the coefficients here and here. So we have 0 and 0, right? So just keep in mind that this is most important to calculate towards this nice step function. There you see the steps, and to solve the equation like this, so to isolate the variables, and then you have it. So it's not too difficult, just practice makes perfect, so you should practice it a little bit and then it shouldn't be a big problem. Thanks for watching. Practice makes perfect. Further exercises with solutions you can find on my website, which is www.worksheets.com.